Your mission is to finish up finding the speeds along each point of the ride. Let's make your life a little bit easier. We just did point B. Guess what? You actually just figured out what other point. Are you awake? Good job. The top of the loop, point F, is also 34.4 meters per second when you round it off. Okay? Why is that? They're at exactly the same what? Height. Therefore, they have exactly the same potential energy. Therefore, they have exactly the same kinetic energy. Therefore, the same speed. So guess what? You only have to solve for what? Point C and point D. Exactly. Because C is the same as what? C is the same as G, E, and what? J. And then D is the same as what? H and K. And assume point D is all the way where? How high? 0 meters. Now, do you have to set up 4 steps again from scratch? No, that's busy work. Since you already broke it all down, you gave me a sample calculation, you can just go ahead and solve it starting from step 3 when you put in the numbers. Now, common question people had when they were working their way through is, where do I start from if I want to do point C now? Do I start from point A or B? And the answer is it doesn't matter. If you call B your start and you're solving point C, then use 60 meters for your initial height, right? 60 meters. And then your initial speed was like 34.4 meters per second. If you pick point A, which is what we did, then do the same thing, but make your initial speed 2.1 meters per second and your initial height 120. In other words, it doesn't matter as long as you're consistent, because whatever energy you put in is the energy you get out. In real life, though, it does make a difference because of friction, but usually you account for that. You calculate the frictional loss to heat and air resistance, all that. But for roller coasters, it's not that significant unless it's like a wooden junkie coaster. Like the Raging Bull, Batman, they're so smooth, you pretty much have most of your energy at the very end of the ride. So they really slam on the brakes. I don't know if you ever noticed.